Hello and welcome to Aleks Explanations Week 2. The first explanation is your first question that's on Introduction to Fractions. All right, Introduction to Fractions. If it's cut into 7 pieces, that's what's on our denominator. And the shaded part is the numerator, so it's 2 out of 7, which would be 2 over 7. For a number line, we're going to do something similar, except this time, this number line has been cut into 1, 2, 3, 4, 5, 6, 7 pieces. So this is out of 7. And you can see that C is 1, 2, past 0, so it's 2 out of 7. Let's go ahead and look here. You can see 7 equal parts, and each one is a seventh. And since C is on the second mark, it is 2 out of 7. For common denominators, the easiest way to find a common denominator is that you can go ahead and just multiply each of the denominators by themselves. So 7 times 4 is 28, and that would be the easiest way to do it. Now you could pick a lower number. If there was another number that 7 and 4 both could go into, you definitely could choose a different number. There's not for this particular one. So let's go ahead and look here. So I'm going to go ahead and solve it a little bit differently here. So Okay. So when I look at this, I see that 7 times 4 is equal to 28. So therefore, both 7 and 4 go into 28. So that's what I'm going to make my new denominator, into 28. Now, I can't just change my fraction and just multiply this and have this 5 over 28 and this 3 over 28, because I have now multiplied the denominator of this one by 4, because 7 times 4 is 28. So in order for me not to change it, whatever I do to the denominator, I have to do the numerator, because essentially what I'm doing is multiplying it by 4 over 4. And what is 4 divided by 4? Obviously, it is 1. So therefore, when I'm multiplying anything by 1, it's just itself. So all I'm doing is just changing how it is being presented. So now 5 times 4 is 20. This one here, 4 times 7 is 28. So again, what I do the denominator, I have to do the numerator, and 3 times 7 is 21. So I have 20 out of 28 and 21 out of 28. Sometimes it may be most beneficial for you to pause the video and do this problem that you have, because as you can see, I'm just following along one after another, and then restart the video again so you can kind of remember what you're doing and apply it right away. Okay, to multiply this, all you have to do is you'll see that it gives a denominator of 1 to my 3, because everything has, all that means is divided by 1. So 3 is just 3 divided by 1. So now the way the publisher decides to solve it is, you know what, let's just go ahead, and since I'm multiplying the numerators and dividing the denominators, instead of multiplying them out first and then simplifying, they notice that, look, why don't I just divide 3 out of the numerator and 3 out of the denominator, and I get a 1 and a 4, and then I multiply the numerators and then the denominators. Okay, this one here, you just follow the question. It's a reading question. You have to just follow it really well. This one says, what percentage of the families, so of the families, how many families are there? 100. The fact that I said of the families means that's your denominator. So what percentage of the families have 2 or more cars? So the only part that I'm interested in here is 2 or more cars. So 42 plus 30 is 72, and it's out of 100, and 72 divided by 100 is 72%. This one says of the families, so that's why it's over 100. How many have are homeowners? What percentage, are homeowners? So 6 plus 42 is 48 out of 100, and that's 48%. Parallel and perpendicular lines. Parallel lines never are going to touch. Perpendicular lines cross at a 90-degree angle. So this first one is neither, because they're touching, but they're not a perfect perpendicular angle. This next one is perpendicular, because you can see they're crossing, and they're crossing at a perfect wall to floor type of angle, which is 90 degrees. You can see that these lines are about to touch, and so they're neither. And these lines are never going to touch, and so they're parallel. Segment, rays, and lines. A segment has a starting point and an ending point. That's a segment. A line does not have a starting or an ending point. It goes forever. You see DC on the line. That's a segment DC on the line, but the line itself never stops anywhere. Finally, a ray has a starting point but no ending point. Now, let me show you the way you can also write these. You can write these here. You can write this as segment EF with a segment over it. You can write this as line DC, but with arrows over it showing that it goes through DC but never stops. You can write this as ray AB, but it has to be A to B because it starts at A and then it passes through B and never stops. So always that spot is the starting point. Complementary and supplementary angles. A complementary angle are two angles that their sum is equal to 90 degrees, and supplementary angles are where their sum is equal to 180 degrees. So for the first example that it gave you, it says I have an angle of 69 degrees. So that means, and if what's the measure of its supplement? So I'm just going to do this. I know if they're supplementary that they form what is called a linear pair. A linear pair means that basically two angles make a line. So I say, okay, this is 69 degrees. We know this here is 180 degrees. So just 180 minus 69 is going to get me 111 degrees. The next one's asking about complementary. Complementary is when I have a right angle. Remember, a right angle is 90 degrees. So it's two angles that their measures together equal 90. So if I have one is 28 degrees, what's the other one? Well, 90 minus 28 is going to get me 62 degrees. Okay, this one talks about supplementary angles again, but it also talks about vertical angles. Okay, vertical angles, the definition of a vertical angle is, excuse me, is when you have a transversal that cuts to a pair of lines that don't touch. So let me show you. So we have this pair of lines that don't touch right now. They're not touching at this point, so we're okay. So, and this here is going to be my transversal. Transversal is the one that cuts through both of the lines. All right, so if I have a vertical angle, so when it says non-adjacent angle, means they don't touch each other. They're across from each other. They're here. Those are vertical angles. These are vertical angles. There's lots of vertical angles. Vertical angles are just literally across from each other. Vertical angles, vertical angles. In fact, this is how I remember vertical angles. I say, well, this one here, and then if I keep drawing it, this one and this one would be vertical. See, just the ones that are across from each other. This one and this one. Okay, supplementary angles, remember I showed you on the last part is that's when they equal 180, so we have lots of those. This one is identifying 6 and 8 because anytime I can have a line and then a line coming off of it, these two are going to equal, if this is angle A and angle B, that equals 180. That's a little m. It means the measurement of angle A and the measurement of angle B equals 180 degrees. So any of these, so you have 6 and 8, you have 2 and 4, You have 1 and 3, you have 5 and 7. I'm going to change colors because you're going to see I also have 8 and 7, 6 and 5, 4 and 3, 2 and 1. Anything that you have that are going to add up to 180 degrees. This is now corresponding and alternate angles. Let me just define what those mean to you. A corresponding angle are angles that are on the same side, corresponding here. It's going to be, I'm starting with corresponding, but corresponding is going to be on the same side of the pair of lines and on the same side of the transversal. Remember, this is a transversal. And therefore, they're corresponding. So I look, okay, what pair of angles are on the same side of this one? So on the left side, so let's go left side of these here, left side, and same side here. Well, we also have what? 2 and 6. Those are both on the same side. That's a pair of corresponding angles. Well, what about 3 and 7? 3 and 7 are both on the right-hand side and above this transversal. Then, of course, you guys probably see, what's the last one? Pair of corresponding angles is 4 and 8 because they're on the right-hand side and below the transversal. So all the ones I circled are corresponding angles, and then 1 and 5 are identified. Okay, alternate interior angles. So now alternate, says this was corresponding, was the same side. Yeah, that's what this one is, okay? Is alternate interior is going to be on the, alternate has to do with the transversal. So alternate of the transversal means on one side, one is on one side of the, if one's above the transversal, the other's below the transversal. Interior, well, this is on the interior of the pair of lines that the transversal is cutting. So alternate, so that's why you can say 3 and 5. You can see them, 3 and 5. One is above it, one is below it. Interior, I have, oh, that says interval. I'm sorry, I don't know why I wrote that. Interior. So what's another pair of alternate interior angles? Alternate means one is on one side, one's on the other. Interior, they're both on the inside. So this one here, alternate, and on the inside. But one has to be on one angle, the other has to, one line, and one has to be on the other line. So those are alternate interior angles, 4 and 6, and 3 and 5. Alternate exterior, this is the alternate exterior angles. Alternate exterior, same thing. I'm going to say alternate of the transversal. So one is on 1, one is on 7. So alternate, one's above it, one's below it. Exterior, remember we just looked at this here where that's the inside, the interior. So obviously the opposite is the exterior. So you can see that 1 and 7 are alternate. One's on the lower side of the transversal, the other's on the upper side of the transversal, exterior, and then they're on the outside. All right, so can you tell me what the other pair of alternate exterior angles are? 2 and 8. Alternate, one's above it, one's below it. Exterior, they're both outside it. And remember, one has to be on one line, the other one has to be on the other line. Acute, obtuse, and right angles. An acute angle is an angle that is less than 90 degrees. So all of these are, this is an acute triangle because there's no angle that is over 90 degrees. This is a right triangle because there is an angle that is 90 degrees. The right triangle, you can see the little symbol. And this is an acute triangle, or excuse me, this is a right triangle because you can see the right angle also. And this is an obtuse triangle because you can see there's one angle that is greater than 90 degrees. So because there exists an angle greater than 90 degrees, we call it an obtuse triangle. Now let's classify different triangles. A scalene triangle, this one here is scalene. A scalene triangle is a triangle where no sides are the same and no angles are the same. So 7, 5, and 11, none of these are the same. A right triangle, we've talked about. Well, this is not only just a right triangle, this is also an isosceles triangle. This is a right isosceles triangle. The reason it's a right triangle, obviously, as you see, the right angle, but the reason it's isosceles is because I have one angle and another angle that are identical. Now, the fact that the angles are identical also means the sides that are opposite have the same measure. So these two sides are the same. In an isosceles triangle, you have two sides that are the same size and two angles that are the same size as well. So you can see in this one here, this one gives you that this is 30, 60, 90 degrees. Well, this is 30, 60, 90 degrees, and it is scalene though, because there's none that are the same. It's a right scalene triangle. Usually we just say right, but you could also classify it as a right scalene. It's a right angle because the 90 degree is scalene because none of them are the same. The last one's equilateral. Equilateral means all the sides are the same and all the angles are the same. Well, they always, in every equilateral triangle, it's always 60 degrees, 60 degrees, 60 degrees, because we obviously have 180 degrees in a triangle, and if they're going to be the same, they have to be each 60 degrees. Okay, Pythagorean theorem. With Pythagorean theorem, you are going to be able to solve the distance of a missing side to a triangle. So first of all, Pythagorean theorem says this: a squared plus b squared equals c squared if the triangle is a right triangle. What's a right triangle? It has a 90 degree angle. So when you see like this, right triangle. Okay, in this, A is equal to a leg, or we call a side. B is also a leg, or a side. And C is the hypotenuse. And the hypotenuse is the longest side. So, and that's the one that's opposite of the right angle. That's the hypotenuse right there. Okay, so let's go ahead and solve it, and this is what it looks like. I have 12, 5, and x. Well, 12 is either going to be, it doesn't matter if I call this A or this A and this B. It doesn't really matter, but I'm going to just say, okay, this one's A, this one's B, and this one's C. It doesn't matter which one's A or B. The only one that matters on this one is that C has to be the hypotenuse. So I'm going to have A squared, so that's 12 squared, plus 5 squared equals C squared. And 12 times 12 is 144. 5 times 5 is 25. 144 plus 25 is 169. And I find the square root of both sides, and I get C is equal to 13. So 13 is my answer, and that's how long my hypotenuse is. So how to construct a histogram. There's a lot of softwares out there. You can Google histogram construction and you can put your data in and it'll Google it for you. But I think you can do this just fine. So the first thing, it gives you already the bins. The bins means that's how wide the bars are on the histogram. And so first of all, from between 61 and 65, I have 1, 2, 3, 4, 5 values. You can see them here circled in red. And so therefore the height of the bin is going to be 5. You're going to notice that these bins touch each other because that's going to be indicating a histogram. They touch each other. A histogram only uses quantitative data. Quantitative data is numbers, and it would mean the order matters. I can't take this histogram and put it in a different order because it has to be 60 to 61 first because that's the lowest numbers, and then the next one, and then the next one. Versus in a bar graph, which we are going to do here. In a bar graph, the order doesn't matter. So you can see they don't touch. So you could see, I could change this graph around and I could have tan first, then gray, then green, then brown, then white. And you can see it's going to look a little different, but it doesn't matter because there's not a certain order from 0 to 10. On the last one, I had it in numbers, so I had to have from 0 to 10 to 20 or whatever. But for this one, the order doesn't matter, so that's why they don't touch, because it indicates that it's a bar graph. For a double bar graph, you just interpret it the same way you would do a single bar graph. The only difference is the purple is referring to the females and the orange is referring to the males. Okay, let's interpret a line graph. And a line graph, it says, what's the least number of wins in the year? You just look for the lowest spot. It looks like 2018 has that lowest spot, and follow that over, and that follows over to 30. And that's in year between 2018 and 2019. So you can see here. Oh, I apologize. I just said 2018 and 2019. Between 2017 and 2018, that's the red line as it goes down. That indicates the least, the dot indicates when it occurred. The line is connecting between the years that it occurred. Okay, circle graph. A circle graph adds up to 100%, and this is how you do it. It says in a poll, students were asked to choose which of the 6 colors were their favorite, and here's how they answered. If 3,000 participated in the poll, how many chose orange and red? So the easiest way to do this is going to add up the orange and red percentages. So I have 6 percentages for orange and 14 for red, so that means 20% of the student body chose orange or red. Then I'm going to multiply that, as you can see here, by 3,000, and that's going to get me 600. So 3,000 total students, 20% of them chose red, and that's going to be 600. Okay, calculating relative frequency in a contingency table. So we have this question asks you, relative frequency just means a percentage is all I'm trying to do. And so this one say, what is the relative frequency of respondents who are independent? So when it's asking for that, it says, okay, relative frequency, again, means percentage. I want the percentage. So I look at independent and I say, okay, that's going to be my total of independent people of how many people I have here is the third row here. Let me get a highlighter out so I can. All right, so we have independent, So we have independent here, and it says I'm asking for the relative frequency of independent. So what I want is I have to add that up first, and 27 plus 17 plus 23, and that's 252 people. So the relative frequency is just each one of them, 27 people here, and I say, okay, of the 250 people here, I have 27, 17, 252, where'd I get that from? I don't know. 67, I'm sorry. Of these people here, I have 27 plus 17 plus 23, and that's 67 are independents. So my relative frequency of independence, when I look and see how many people were surveyed, that's 252. So remember, I'm looking for percentage, and I want who are independent, so that's going to be 67 over 252. Is that the only thing it asked for? I think it does, yes. Okay, for this one, we're making a reasonable inference based on proportion statistics. In a recent study, 20 males used a weight loss supplement, and all but 6 of them lost weight. In the same study, we had 100 females who used the supplement. All but 14 of them lost weight. So we're going to see if where it was more effective or less effective. This one says the new weight loss supplement was less effective on blank because this blank percent failed to lose weight, and this percent for women or men failed to lose weight. So we're going to just go ahead and solve them, and we say, okay, so we have 6 out of 20 of the males, or 30%, failed to lose weight. So 70% did lose weight. Among the females, we had 14 out of 100 that we had, it said in ours, did not lose weight. So that means that we had 86% lost weight. So now we can just fill our percentages in. And so we say the new weight loss supplement was less effective on males because 30% of them failed to lose weight, where only 14% of the females failed to lose weight. Okay, mode, that just means the most common one that occurs. So when you look at here, you see, okay, I'm going to circle them and see if I can order them, and I can see which one occurs the most, and 7 clearly occurs the most. It occurs 5 times, and so that's the mode. So we're going to do mode again, but now we're also going to do range. Mode is just the most common, so if we order these from least to greatest, that's probably the easiest because we're going to need to also do the range. So the range is just the greatest minus the smallest. So the biggest number is 8, the smallest number is 3, and so the range is 5. You do not say it ranges from 3 to 5. You say the range is 5. It's a singular number. Then mode is going to be the most common. Finally, mean and median. I guess not finally, but next, mean and median. Okay, mean is just the average. You guys have learned how to do the average since you were younger, where you add all of them up and divide by the number. And median is the middle number. So to do median, we're literally going to do this. This is the way I like to do it, is I say, okay, how many do I have? So if I have 5, then I'm going to do my middle number. So I mean, with this many, it's pretty easy to do. I say, okay, so I'm going to cut out this first pair. I'm going to cut out the next pair, and the median's in the middle. You have to be careful and make sure you cut it out as a pair. This is cut out because otherwise then you're going to get misaligned. Another way you can do it is this. You can take the number of data. You can always add 1 and divide by 2, and that gets you which point of data is your middle. So that's 6 divided by 2 is 3. So that means it's my third data point, which you can see 1, 2, 3. So that's my median. You can, when it's a small data set, it's really easy to see as well. For your mean, simple, add them up and divide by 5. Now we're going to go into a little bit more complicated by changing and see what happens to the mean and median. If you're not sure, you definitely can just put them in your calculator, do the particular change, and see what happens. So I have these 7 data points. Now it says that this is what's going to happen. I'm going to change this data point, 372, and instead of it being there, it is going to now change to here in this spot. I'm just putting in numerical order, 589. Excuse me. Okay, so what's going to happen to the median? Well, let's calculate what the median was before. Let me just erase this real quick and find the median first. Okay, so the median, remember, is my middle number, and I have 7 pieces of data, so this one is the one that's smack dab in the middle. So this number here is moving from below the median, canceling out, and moving here to above the median, which is now 589. Since I've moved something from below the median to above the median, you can clearly see that this is no longer the center number. and it's shifted over one spot. And now 585 is the new median. The mean is obviously going to increase as well, because instead of me saying 372 plus 398 plus all of this, I'm going to do a bigger number, and so therefore it's going to increase. So you can go ahead and calculate them to see how much they increase by. Okay, the weighted mean, this just allows me to get something like, in one of my classes, I have 30 students, right? And they got an average of an 80 on the test. But then another class, I have 20 students, and they got an average of an 85 on the test. So in order to do weighted mean, I would use the different class sizes to be able to compute what the entire class average is. And the way you're going to do this is this. So I have number of babies is 3 and the birth weight is 4, 8 and 6, 13 and 7. So the way you're going to do this is you're going to multiply all of these here and add them together. Before it would say, if I ask you to find the mean of this, you do 4 plus 6 plus 7 divided by 3. But we actually have more than 3 pieces of data. I have 3 4s. I have 8 6s. And I have 7 13s. No, I have 13 7s. So essentially what I'm doing, I'm adding all this up. So isn't that just 3 times 4 plus 8 times 6 plus 13 times 7? You are welcome just to add 4 plus 4 plus 4 plus 6 plus 6 plus 6 plus 6 and so forth and so on. And we're going to divide that by the total, and the total is this. This is how many babies there are. 3 plus 8 is 11, plus 13 is 24. So we're going to divide that by 24, and that is going to get our weighted mean. Okay, interpreting a tree diagram. How many outcomes are there? The outcomes are on the right-hand side. It says outcomes, so you just count those up. How many outcomes do not have Sam being chosen? So just count how many do not have Sam being chosen, and then count how many Linda and John have being chosen. A bag with 10 marbles has 2 yellow marbles, 4 blue marbles, 4 red marbles, a marble chosen from the bag at random. What is the probability that it is not yellow? All right, so what we're going to do is we're going to just see we have how many total. If we add that up, we have 10 plus 2 plus 4 plus 4, and so that's going to be 20 marbles. So I have 20 marbles, and what's the probability of it not being yellow? Not being yellow. Well, if I have 2 yellows, then don't I have 18 that are not yellow? Out of 20. Let's go ahead and remind you what all of these signs mean. These are less than, greater than, and equal to signs. The reason I remind people, it looks like a less than. See, it looks like an L. So the smaller point always goes, though, to the smaller number because it's pointing to the smaller number. See, it's a smaller side. The larger point, you can see it's open. The larger side is going to the larger number. So on a number line, let's go ahead and graph these just so we can see. When we see -3 and -10, think of negative as being in debt. Would you rather, what's better, being in debt $3 or being in debt $10? Obviously, hey, I'd rather be in debt just $3. And so this is a bigger number because if I make $20 that day, I only have to take 3 out of my paycheck to pay off my debt versus if it's $10, it's worse. I have to pay $10. So think of negative as being in debt, taking money out. So 5 is going to be smaller than 2 because it's negative. And 8, and then this is obviously negative as being in debt, and 11 is having money in your pocket. So I would definitely rather have $11 in my pocket than owe somebody $8. Absolute value of a number. The purpose of absolute value of a number is the distance. The reason we use absolute value is because if I have a number line and I have something from you can see the distance here is 5 and the distance here is 5. But because this is negative, often people may say, well, it's a distance of -5. But no, you can't have a negative distance. So that's why we would use an absolute value. But absolute value, what the sign does is it always makes it positive. So this is the absolute value of 5 is 5. The absolute value of -5 is still 5. It just means that is the distance. So distance is always positive. Integer or not. So an integer is just a number that is not a fraction or a decimal. So that's what all an integer is. So we'll go ahead and look at these, their explanations really fast. So you have -12/4. Well, if you divide that, that equals -3. And that is a number without a fraction or a decimal. So yes, it's initially in a fraction, but when I simplify it, it's not a fraction, so that's an integer. Same with -24/6. 4/5, if I divide that, I'm going to get a decimal. I'm not going to get a nice even number. So that is not an integer. 2 is, and then -8.62, of course, is not. Last topic, rational or irrational. A rational number is a number that can be put into a fraction. And if it can be put into a fraction, then it's rational. If it cannot, it's irrational. Well, let me actually clarify that. So if you have a decimal that does not repeat, and like if you have a decimal point 1, 2, 8, 3, 1, 5, 7, 3, 7, 2, and you see it keeps going and going and there's no pattern. That's not rational. And I cannot put that into a fraction. But 0.66666, that keeps going, that's actually 2 divided by 3. So that would be rational. So you see here any of these that are rational or irrational. This one stops, and so that's okay. That's rational. It either stops, the decimal, so to be rational, the decimal either stops or repeats, has a repeating pattern. Pi is irrational. Pi is always irrational. It's 3.1415789 something, I don't know. And so it is irrational because it has no repeating pattern and it never stops. This one here repeats. It's -51.3131313131, and it keeps going 3131, so that is rational. Square root of 16 is 4, and so the square root of 16 is rational. So because that's obviously here, and you look at the square root of 6, if you put the square root of 6 into your calculator, you can investigate what it is. So go ahead and try that and put the square root of 6 into your calculator, and you get a really long number that does not repeat and has no and does not stop. So that is irrational. All right, I hope this helped you. If you have any other additional questions, please let me know.